So today we're going to look at a couple of things. Lesson 54 for the most part we're going to skip. It's representing solids. It's a little bit more of an art class than it is necessarily math, but it's basically looking and representing three-dimensional solids, how we can do that in 1-point perspective and 2-point perspective, how we use horizon, and a couple of those different things. But today we're going to focus mainly with lesson 55, so when we get turned on over there. I believe it's page 361 in your book. It may not be. That's what it is in my book. Okay. So let's see. What we're going to talk about today is the triangle midsegment theorem. Triangle midsegment theorem. Let's see. Can I get somebody to read midsegment of a triangle? Let's see. Jesus, would you read that for me? On over in lesson 55, midsegment of a triangle.
Midsegment of a triangle is a segment that joins the midpoints of two sides of a triangle. So if you want.
Yeah, keep going.
Every triangle has three midsections.
Midsegments, okay. So what we're looking for here is we're going to look at a triangle. We should hopefully know what a midsegment is or what a midpoint is. Okay. Here I've drawn up here just kind of a basic example of that, where we see that D is the midpoint of AC. Okay, F is the midpoint of CB, E is the midpoint of AB. Right? It is the points, and then I'm drawing a line across from D to E, E to F, and D to F. Okay, what we're going to look at inside and what we'll see described later is the triangle inside, which is called a midsegment triangle. Okay, midsegment of a triangle. It's a segment that joins the midpoint. So we know how to find midpoint, right? Can anybody give me a brief rundown of of how we find a midpoint on a coordinate plane? How do I find a midpoint on a coordinate plane? Because we might need to do that, right? They're going to take some things like this. Eventually, they're going to put it on a coordinate grid. Okay, x1 plus x2 divided by 2, y sub 1 plus y sub 2 divided by 2 is going to give me the coordinates, right, to find a midpoint. So if they gave me coordinates of A and they gave me coordinates of C, I could find D, right? If they gave me coordinates of B and I had coordinates of A, I could find E, I could find F, and I could make those midpoints, and then I could end up finding the midsegment triangle. Is that correct? Hopefully. Okay. All right, let's kind of keep going on here. Okay. Now, the midsegment is always half the length of the side that does not have a midsegment endpoint on it. Therefore, DE, this line right here, is going to be half of the side opposite of it. Okay, the side that it does not share an endpoint with. So DE is 1/2 of CB. DE is also parallel to CB. Okay, so we'll learn two things. We learn that this is half, and we learn that it is parallel. Okay, and somebody identify, let's see, what is DF? What is it parallel to? Brady. More than that. DF is parallel to, it is parallel to EB and AE, so could we stretch that? AB, good. All right, so not only is it parallel, but it's also half the length, okay? So if I knew what DF was, like let's say for instance that DF, we could say, I know that that's 4, right? My 4 is not very good. But if I knew that DF was 4, could I find the length of AB? What would AB be? It would be 8, right? And I could do that all these different ways around. What about EF? Somebody else. What is EF parallel to? Austin. AC. And let's work at this the other way around. Let's say that I knew that AC was 10, right? Would I know what EF was then? What would EF be? It would be 5. Okay? All right, so it works in both directions, right? If I know the whole length, I can find the mid-segment length, right? And that term mid-segment kind of should give me that clue that it's going to be half, right? It's made up of midpoints, which are half the distance, right? So it's no surprise to us when a mid-segment is half the total segment. Okay? So far, does this make sense to us? Do I get some thumbs up, thumbs down? Most of us sideways on this. I don't think that there's anything in here that's overly difficult. Okay. Coming on to my next slide, we're going to look at Theorem 55-1, and Theorem 55-1 pretty much states exactly what we've just stated. Okay, the segment joining the midpoints of two sides of a triangle is parallel to and half the length of the third side. So I've tried to show you one that's oriented just a little bit differently. I'll get my cursor out of the way. Where we see that DE is parallel to AB, and it is half the length. Okay, so if AB was 7 minor, what would DE be? It would be 3.5. Okay? If DE was 4.5, what would AB be, Erica? 9. Good. All right, so we've got kind of a basic understanding here. Great. Okay? We'll move on a little bit further. Theorem 55-2. Okay? If a line is parallel to one side of a triangle, and it contains the midpoint of another side, then it passes through the midpoint of the third side. What they're saying is that since DE, we know that DE is parallel, okay, to BC, and BD is congruent to DA, therefore, this is our therefore statement right here, AE is congruent to EC, okay? If it's parallel and contains a midpoint, then the other side is a midpoint. Okay, that's the only way for DE to become parallel to BC, is for it to be, and for it to be congruent, or even half. It has to, this point E has to be a midpoint. Okay? All right. I think just about ready. We'll look at one more thing here. A midsegment triangle is the triangle formed by the 3 midsegments of a triangle. We've talked about that. Triangle DEF that we see here, if I scroll down a little bit, is a midsegment triangle. Midsegment triangles are similar, right? What do we know about similarity? Similarity of two things. What are they? They're the same but different. How are they different? Kind of. Their lengths are different, but what? It's kind of a big P word here. Not perpendicular. Okay, not parallel, but good. We're running through our P geometry words. Proportional. Okay, proportional. Starts with P and ends with proportional. Okay, so midsegment triangles are going to be similar, which means they're going to be proportional to the original triangle. This DEF is proportional to this triangle right here. It's proportional. Okay? Remember, and what should the proportion be? Right? Triangle DEF should be exactly 1/2 of triangle ABC, right? Because DE is half of AC. And I don't know that I put a letter down here. I think there's an F that you don't see. But DF is going to be half of BC. Okay? EF is going to be half of AB. So therefore, the perimeter is going to be half. Does that make sense? All right, so the proportion should remain the same. All right? And these triangles should be, for the most part, kind of congruent to each other. So this to this to these, all four of those triangles will have a relationship. Okay? They're similar to the original triangle and to the triangles formed by each midsegment. Okay? So we wind up with this statement. Triangle ABC is similar to triangle EFD, is similar to triangle ADF, is similar to triangle DPE, is similar to triangle FEC. Okay? All right, from here, let's look at some of our work. Okay? Oh my. And it's gotten all discombobulated on me. Let's go in here and fix this. Okay, let's look at question number 1. Triangle ABC, AB is 3. We can see that here. AB is 3. BC has a length of 5. AC has a length of 6. Okay, find the length of midsegment XY. Okay, Brady's got an answer. Anybody else got an answer? Caleb's got an answer. Jesus and Mick have got an answer. Mick, what's your answer? How did you get that answer? You divided 3 by 2. So he got XY equals 1.5 because XY is parallel and half the length of AB. So you take 3 divided by 2. Very good. Okay. Let's move on. Let's try another one. Okay. Number 2. In triangle ABC, it says show that midsegment KL is parallel to AB and that KL is 1/2 of AB. And what you're seeing here for the answers is everything that shows up on this right-hand side. So there's a lot of information there. Let's see what we can do on our own without looking and going to all that different information. If I want to show that triangle ABC, we want to show that midsegment KL is parallel to AB. How do I show that two things are parallel? Two lines are parallel. Brady. They have the same slope. So first, let's find our slopes. What is slope, Darian? Rise over run. So how would I find a slope of KL? Go up 1 and then over 4. So what is the slope of KL? 1 over 4. Okay? So let's find the slope of AB. Okay? Let's see, how far up is it going? It's going up 2, 1, 2. How far over is it going? 8. So it's going up 2 over 8. Can I reduce that to 1/4? So do they have the same slope? Okay, so we've shown that they both have a slope of 1/4. Okay? Now we need to show that KL is half of AB. When we're talking about that, what are we talking about? We're not talking about slope anymore. Length. How do I find the length of a segment? There's 2 ways. I'll accept either one. 2 formulas. One's a formula, one's a theorem. How might I find the length of KL? I need to cue some Jeopardy music. Brady. Okay, tell me how to use the Pythagorean theorem here. I'm going to erase some of these lines. Go to a different color. Pythagorean theorem. What would I do? Okay, so you're saying from K up that was 1 and from over it was 4 and that formed a right triangle where KL was the hypotenuse? Okay, so tell me how to use that information. equals c squared, or we could even refer to that as segment KL squared, right? So, I mean, we see the exact relationship there. What's 1 squared? 1. 4 squared? 16 equals segment KL squared, okay? So 17 equals segment KL squared. Square root both sides, okay? Square root both sides. Can I simplify the square root of 17, or is it just pretty much the square root of 17? Square root of 17. So let's put square root of 17 right there, and we're going to hold on to it. Now, if KL is half of AB, what should be the length of AB? Two radical 17 or square root of 34, right? I mean, that would be double. Let's see what we get. I'm going to go ahead and erase this one. Now, what else could I have used besides the Pythagorean theorem in case I was listening to this recording and I wanted to do something else? I didn't understand that. I could have used the distance formula. In fact, let's see if we can use the distance formula here. If I'm going to use the distance formula on this one, I'm not going to use the Pythagorean theorem, so what do I need? I need to find the distance of A and B using the points, the coordinates, okay? So let's go ahead and put that information in here. It's going to do exactly the same thing the Pythagorean theorem did, okay? Okay? What do I put in my first set of parentheses here? Negative 4 and 4. So you're putting both the x and the y of A in the first set of parentheses? The x value of A and the x value of B. All right, so you're going to do negative 4 plus 4, negative 4 minus 4. What is it? It's minus 4. And if we need to, we can go back. We can always go back to the back of our book and look up distance formula because it should be x minus x, right? X minus x1 minus x2 squared plus y2 minus or y1 minus y2 squared. All right, so we've got the 4 minus 4 squared. Let's go ahead and get our y's. Negative 4 minus negative 2 squared. Okay. Let's simplify that. What's negative 4 minus 4? Negative 4 minus 4? It's not 0. Negative 8. Negative 8. All right, so we'll put negative 8 here and square it. What is negative 4 minus negative 2? Negative 2, very good, because that became a positive. We're going to square both of those. All right. What is negative 8 squared? 64. Good. Plus what? 4. All right, that gives me the square root of 68. Square root of 68. Can I reduce or simplify the square root of 68? Okay, do that using our cake method. What can I divide 68 by? 2. Okay, and that's going to give me 34. That's going to be 2 and 17. And can I take the 17 out? No. But I can take the 2's out, and I'm going to get 2 radical 17. Does that show me that AB is twice or KL is 1/2 of AB? Yes, it does. Okay? And I'm not even concerned. You could look over there to the right-hand side and see what your answer should be. I'm not as concerned with that as you guys knowing, one, how to find slope and how to find distances and see the relationships there. Let's see, we can look through, I think. Okay, we're looking for one where it says KL, slope of KL is 1/4, slope of AB is 1/4. Length of KL is radical 17, length of AB is 2 radical 17. Okay, that matches up. B, you see that shows slopes of 1/3, so we know it's not B. On C, we got 1/4, 1/4. But notice on length it says radical 15, 2 radical 15. We go down to D. We see 1/4, 1/4. Radical 17, 2 radical 17. What's the difference between A and D? Anybody spot the difference between A and D? Because if I saw this question on a test, I might get this wrong. Notice on the very first line, they're looking for the coordinates of L. What are the coordinates of L? Should be 0, 0. Is A correct? No. Right? They give me coordinates of 4, -2 for L. I want to go down to D. I want to pay really close attention. Notice L has the right coordinates. D has the right coordinates for L. That's the only difference. They had all of our other work right. Okay, it'd be very easy to get that question wrong on a test. Okay? Let's come down here. Let's look at question number 3. Vanessa wants to measure the width of a reservoir. She measures a triangle at one side of the reservoir, as shown in the diagram. What is the width of the reservoir, which is represented by BC, across the base? I'm going to look for some different answers. I know that you've got it. Austin? Would be 300. How did you find it? It's double XY. And we know this because, one, we notice that AY and YC are congruent, right? We notice that AX and XB are congruent. All right, which means Y and X must both be midsegments, which means that if XY is a midsegment, then it must be parallel to BC and 1/2 of BC. Therefore, BC is twice the length of XY. So we take XY and multiply it by 2. We get 300. Okay? All right, let's see. Number 4, these are those lesson 54 questions. Draw a cylinder in 1-point perspective. Because it's asking for a cylinder, we'd be looking at something like A. We're drawing it back to a single point. Okay, and these all kind of give me some different things. This is not a cylinder 1-point perspective. Neither is that because it's not a cylinder. So you would get, you might see a question. I'll probably take a lot of them off, so they're not really necessary. They're on number 4. Let's look. Number 5 is kind of the same thing. 2-point perspective, just so you're aware of this, draws things back to 2 points. It's just what you see here and here is the 2-point perspective using the letter I. So B is our answer there. Okay. A is an example of 1-point perspective. Okay, let's look at number 6. FG is a midsegment of triangle CDE. What are the values of X and Y? Let's see. Mariah, can you help me out here? Can you tell me what the value of CE would be if FG is a midsegment? CE. FG, and I'm hoping you can see it from back there, FG is 11. So what is CE going to be? All right, let's kind of go back to some of our notes. Okay. Let's see. Triangle midsegment theorem. In here, DE, okay, is the midsegment. AB is the side that it's opposite. DE is 1/2 of AB. A midsegment is always half of the side that it's parallel to. Okay? So let's go back to our question. Okay? FG, is it parallel to CE? FG is right here. Okay? Is it parallel to CE? Okay? So if FG is 11, what is CE going to be? All right, let's come back here again. If DE was 4, then AB would be 8. Okay? Because DE is 1/2 of AB. All right? So I would have to double it to find AB. Does that help you out a little bit? Let's come back. If FG is 11, what is CE? What? What is double 11? $22. Okay, 22 is CE. All right. Let's see, Mick, if FD is 8 and FG is a midsegment, what is Y going to be? What? 8. 8, right? Because it is a midsegment. So that length is going to be the same. All right, that should give you a pretty good start on this. You guys have your assignment in your instruction notes. You should know what you need to have done for tomorrow.